Already?
And normally
There
that
you
only
go.
happens after the first exam.
Sierra College is too small to offer honors courses. We just don't have enough students. So we don't have enough students to fill another section to say Math 33 solely devoted to honors. What we've done instead, and I know this because I was in the honors board when we formed this whole thing. What we do is for individual classes, I should say for individual students within individual classes, we can create contracts, honors contracts. It's just projects beyond what you see in the classroom in the standard course that students complete and get an honors designation on your transcript. Some transfer institutions would do nice things for you. For example, give you priority registration, things like that.
Okay.
So it does come in handy depending on where you're transferring. I think it's great to do anyways, regardless of what the benefits are in that fashion, because you get something out of it. You learn something from it. Is there anybody here who's interested in honors? Oh my goodness. Oh, you're killing me. Really? All right, maybe.
If we want to try, but then kind of realize we can't do it, is there?
If you sign a contract, you can back out at any given time. Excuse me. It has no effect whatsoever in the grading course. Now here's something I pushed personally through on the honors board. You might not like this. The board was emphatic. They said to get the honors designation, you need to earn an A or B in the standalone course. And I said I did not like that. And so I made sure that we had a rule in this that says the following. If the professor so chooses, he can have more stringent requirements. And in all my honors contracts, I do demand that the final grade will be an A. And I even write that in the honors contract. Something else I do, which is unlike maybe some other professors, I do not allow students to write the contracts. I write them completely on my own. And you read them, and if you want to do it, you sign them, and we'll submit those. Yes, sir.
Do the honors projects go toward your grade?
No.
So
No, we do not allow them to go towards your grade.
the other question I have is, given what we've learned in mathematics so far, have we learned enough to complete any of these contracts? I mean, are we going to have to learn some things outside the scope of the course in order to...
Oh, I see your point. No. Everything you need to do to answer these questions, you will get out of class.
Okay. And they're specific to this individual class? Like, so say we got a honors project
Yes,
for DE,
they're
it's
specific
specific
to
to DE? Okay.
Something else I do with honors, I mandate that we sign these at the very last minute possible. Because I want you guys to have a solid feel for what I expect in the course before we dive into extra projects. Make sense?
And that's next Thursday?
I think so. Is it next Thursday?
I just heard my last class. That's
Yeah.
Okay, good. All right. That's what I thought. It usually is the end of the fourth week of the semester.
Okay.
Anyway, in terms of honors, anybody else have any questions? I can't think of anything else.
So go to your office hours, just ask for a contract.
No, I'll get a better feel for who in this room wants to do honors after this week.
I'm still a little bit confused about the purpose of the honors projects. I mean, I know that that's the extra work you do in the course, but as far as what you get on the project, what you do, I mean, how does it factor in?
I just say yay or nay to the project, your work. And if everything's good, which it always is, then you get an honors designation transcript.
Okay.
I shouldn't say that. There are plenty of students in my past who decided midstream they don't want to do any more honors contract. They're going to bag it.
Okay.
That is the case. But I've never had a student try the honors and say, this is too hard, I can't do it, because when I give an honors contract or an honors project, you get stuck, you come to me, I'll unstick you and push you a little more in that direction. And then you get stuck again and I push you more. I mean, that's just how I operate with the honors projects in my courses. I do seem to have more success with my honors in this class more than the other ones.
Why so?
I don't know, but I imagine it's because the students, you students, are more mathematically mature,
Okay.
I think.
Do you offer those in every class, or is it just this one in 32?
I have done it in every step 30 series,
Huh.
if a student asks. yes.
Okay.
What is, like, if you can describe briefly, what does a typical project include? Is it one really complicated problem?
You guys want the first project? Here it is. I'll type this up for me for you, by the way. But here's the first one. If you have a curve that has a reflective quality of a parabola, is it necessarily a parabola? No. By the way, the answer is yes. Now prove it. That's the first question.
Don't you also have to talk about a fixed point or whatever the analogy would be to the focus of the parabola?
Oh yeah, so I think the answer to the question, you might want to do something like this. Fix the focus of this curve, whatever it is, at the origin, maybe. Now, if you have the reflective quality that you bounce off that thing and you're in parallel to, say, I don't know, the y-axis, see if there's enough information geometrically to generate a differential equation, and then use it to solve a differential equation to come up with a solution. But by the way, in the end, the solution better be quadratic function.
So we have to make the assumption that there is a fixed point such that.
Yes, that's what I'm saying. If you got a curve that has a wonderful reflective quality of a parabola, I am saying, let's make the assumption. Oh, I saved it. Awesome. Let's make the assumption of a fixed point and a fixed line, so that whatever this curve looks like, when I project away from that fixed point, I hit whatever that curve is and run parallel to the center line of symmetry, or run perpendicular to that fixed line. The directives. Yes.
You say this is the first question. How many questions are there?
Well, I love functions that are called hyperbolics. So I'll probably slip with something like that as the first project as well.
Okay.
So for the first project, those 2 questions.
Okay.
I've got something really cool for the second project. It's just so ambitious, I don't know if I can get all my thoughts together to create it.
And so how long do we have to complete the first project?
I don't really put time limits on it.
Okay.
I just expect students to get it done within a couple of weeks, I guess.
Okay.
I would prefer you to type these up.
Okay.
Yes, sir.
Can we just assume that that's a sign, that's the first project?
Yes. Or how about saying that's the first question of the first project?
So we can start thinking about this, and
Absolutely.
when you finally formally give it to us,
You could have it done
start.
eventually. Or have a good start. Oh, you guys, where are we at? We are solving first order differential equations. And what we've done so far, shoot, it's the 3rd week, you guys. We've hardly done anything. First type. Separable. In other words, you got a differential equation that can be expressed in this form right here. And I think when it comes to first order linear, it's simply a differential equation that could be expressed in this form. Gosh, what else do we have? What's that? True, but that's what we used to solve this. That's all we've had, not much. So today, we try to fit. So I want to talk about a differential equation that I will sometimes subclassify as first order homogeneous. Now, first things first. If I got a function f that has equality, but it is a function of 2 variables, and if in evaluating f at x comma y, I get the same thing as evaluating f at, I don't know, kx comma ky, I might subclassify that function, not a DE, just a function, as a function of 0 order. Now, a differential equation will be subclassified as homogeneous if it can be expressed in the form dy dx being equal to f as a function of 2 variables where f itself is of 0 order as a function. Now that might sound complex, but in practice, to determine whether or not you really satisfy that condition is a piece of cake. So let me show you some easy examples. Oh, by the way, how's the other quiz coming?
It's coming.
Well, not for you, Alex. It's coming. You're not done yet. How many finished within the second quiz? Guys, I was being selfish when I said the due date's tomorrow, because I'm here all day and all night today, and I know I'm not gonna have time to grade it. I should be able to slip in the one you just gave today, but.
Okay.
You guys, I gotta stall because I really don't have examples for you. However, I did cheat. I created some examples. So I take
Doesn't that mean you have examples for us?
I do have some, I just don't want to create them out of thin air. I want to do that, that'd be nice. You know, when I look at this equation, this differential equation, it screams out at me that it's homogeneous first order linear. I said linear, didn't I? I meant first order homogeneous. It screams out at me because when I dive in here and I try to multiply top and bottom of this dE by 1 over x, I get this. So in a first order differential equation, if I see y over x is all over the place, it screams out at me that it's going to be homogeneous. And my technique is to get rid of the fractions. My technique is to use subamount. So if I come in and make this proclamation, and I try to substitute u in for y over x all over the place, it means I'm going to have to do something about y prime, which is dy dx. So, define dy dx. If I differentiate both sides, don't I get a headache? So to differentiate both sides, I got to use the quotient, right? So I cheat. Get rid of fractions before I relate du dx to dy dx. Now keep in mind that y is understood to be a function of x, and if u is equal to x times y, then u is a function of x. So I will differentiate both sides with respect to the understood independent variable, namely x. Does that give me x du dx plus u being equal to dy dx? So I guess I've got multiple substitutions to apply. For example, another name for this dy dx is going to be my x du dx plus u, but another name for the right-hand side is a 1 minus u over 1 plus u. You guys, so far so good? What's next?
Wait.
I bring the u over. Right?
I'm just trying to see how you got the 1 minus u over 1 plus u.
Oh, I did something just straightforward, Brad. I
Okay.
merely replaced y over x with u.
Ah,
That's why my first step, I forced myself to see y over x. If I can't
Okay.
force myself to
Okay.
see y over x all over the place, I commit to this u sub.
I see what you did. Yeah.
And I maintain that if I do as someone just suggested, namely subtract u from both sides, I'm left with x du dx being equal to, I don't know what I'm left with. I'm sorry. I gotta slow down. Is that gonna be a 1 minus 2u? Is it a minus u squared? All over 1 plus u. Oh, but shoot, this d is now separable. As a matter of fact, with the substitution, you'll always generate a separable. And I'll separate variables. Does that give me a u plus 1 over negative u squared minus 2u plus 1? And a 1 over x. What's next? Oh no. Shoot, you guys. I didn't know it was going to be that nice. Darn it. That's so disappointing. What's next? That was pretty good. What is next?
A little off.
I was in class a couple semesters ago. I had a student named Ben Smith. You know Ben Smith? And he's sitting there with his laptop one day at like just a second week of class. I think it was this class. And in the middle of class, he turned the computer around so I could see the screen, and he was counting jeepers. And he said, I'm gonna collect data, I'm gonna see how many jeepers you have and see how it corresponds to the level of difficulty of class. He wanted to see if the number of jeepers corresponded to that. You guys.
So-
I just have a but.
You could take out the negative on the bottom and then factor the bottom, and there should be a u
It doesn't
plus one
factor
term.
into
Oh.
Oh
yeah.
Just state the answer.
What was
You
the
could just do a
Natural
u
log
sub.
of negative
Yes.
square
What
minus
was the
2.
results of this study?
Negative natural log.
You know what, he never conducted it. He never really correlated.
I'll
Yeah.
start it.
Yeah.
You start, okay.
Natural log.
Yeah.
Yeah,
So
pull
you're
up.
saying negative 1/2?
Pull up
Natural
the
log.
negative.
How many has it
yeah.
been so far?
Natural log. Absolute
Yeah.
value negative e squared
Yeah.
minus 2 plus 1.
Anyone know how many times he said it so far?
No.
Jeepers. I don't know. Couple.
Two. Okay.
You guys happy?
Yep.
Not yet. I'll slow down. Oh, I see your point. I got you. What's next?
Eliminate the natural logs.
Bring the 1/2 to
Or you can multiply both sides by 2.
So multiply both sides by -2, exponentiate. Doesn't it tell me that y squared over x squared plus 2y over x minus 1 is equal to, I have no idea. You guys, are my math skills there? Oh, by the way, do you guys think in this example I can get away with not solving for y completely?
Probably.
I just think it's too messy. But I suppose I can get rid of the x squareds. So this give me y squared plus 2y times x, excuse me. I forgot my factor of x, jeepers. And I got a minus x squared being equal to a. That looks nicer, I think. Yes?
Can you explain why the signs are different in the ln than they were in the denominator?
I just thought they looked nicer. And after all, if I keep this negative signs here and I pull one out, the answer I have -1 is just 1. It just looks nicer. But you don't have to listen to me. Yes, sir.
So is that something acceptable to do when you say solve to leave it in that form, or does solve generally mean you want a y equals?
Yeah, I think when you solve a DE, if when you isolate y completely, it just looks too horrendous, I'd stop. You have to confess, I could solve for y, it's just solve for y in here, I use a quadratic formula, I got square roots in there, I just don't think it would be aesthetically pleasing to the eye. And sometimes it'll be impossible to solve for y in terms of x anyways.
Because when I was looking at the solution for the first take-home quiz, I think you had stopped when you had just like the y on one side, but like not just solve for y, but like ln of y and all that.
And I didn't isolate it completely, yeah.
I don't think so.
So in some examples, I just leave it as an implicit solution. Yeah, I agree.
So it is okay if we do that
Oh,
sometimes?
yes. And there'll be plenty of times where it's not even possible for you to solve for y in terms of x. Sir?
I'm curious what happened to the y plus 1 before you actually integrate. Where does it?
You mean this one right here? Oh, sir, you know what I was doing? Can you imagine multiplying, hold on, let me choose different colors so you can see what I'm changing. Imagine multiplying top by -2. It's not legal. I better compensate. And now check this out. If z is equal to this, isn't that dz? So I'm really just integrating 1 over z, which is a natural log of z. But there's my z. Oh, by the way, my -1/2 is only great. I was just applying a z set. Come on, you guys attack me. Anybody else? Yes.
Where's the -1/2 come from for a natural log?
I did this with my other Christmas color. Multiply both sides by -2. Brought this up. So when I exponentiate, I just get a 1 over x squared. I suppress the absolute values because they're superfluous at this point. Anything else? Okay, good. Let's keep moving. I have more examples. I just don't have a black pen. Yes.
2 questions. First of all, if I do complete this survey, can I skip one of the contracts.
No, I don't want you to do them. That's still too
Okay,
hard.
second of all, I am going to need a large sample size, so everyone is gonna have to tell me individually how hard this class was.
I'm sure you'll get the feedback.
Please help me.
Well, with my second example, I have no clue what it is. How about an x squared dy dx being equal to an xy plus y squared. And I have a boundary value condition. Well, you guys, here too, like my last example, I just think this screams out at me homogeneous because I see y over x all over the place. If I merely divide both sides by x squared, doesn't that generate this? Is it just simply a y over x plus y over x twice? And can I steal my board space? Having already committed for my last example that particular substitution, let's plug everything in.
2 looks like a question mark. Alright, that's better.
And committing to my substitution, I guess that gives me my x du dx. Plus my u being equal to, I don't know, is that a u plus u squared? You guys, now I feel like I'm insulting your intelligence. I'm sorry these examples are so easy. I didn't realize that. So, does that mean with this level of complexity that I can apply the French technique?
I'm so confused. What is a French technique?
Yeah, I'm not talking, just being a mime. Well, because it's so easy. And I think that means negative y over x is equal to stuff. But cheapers, you guys, in this example, I think it's fair to say it's easy to isolate y in this equation. And I'm left with y being equal to...
X over y. X over y. It's one overused.
My apologies. I didn't even see that. You're saying 1 over u is going to be the reciprocal of y over x. I agree. I still think it's fairly straightforward to isolate y, though. Does that give me y being equal to... Is that a negative x over stuff? But shoot, with the original question, I guess I did give you, indeed, a boundary value condition. I'll plug everything in to find that particular constant c. So when y of 1 equals 1, this gives us 1 being equal to negative 1 over c. So c is equal to negative 1. So my particular solution, did I say negative 1? So natural log of the absolute value of x minus 1. That sounds kind of clunky, doesn't it? Sorry. We can make it more pretty. You guys, can you give me a little feedback? You're too quiet. Is this boring and easy? Or really difficult?
It's pretty easy. Good.
Then
Till
how
the
about
exam.
something else? I have another type of DE for which I make some kind of substitution. I'll subclassify this type as Bernoulli. And I maintain that a differential equation is subclassified as a Bernoulli DE if it can be expressed in this form. dy dx plus some function in x times y is equal to some other function called q of x in x.
So what's the difference between that and the first order linear?
Oh, I'm so glad you asked. There isn't. So I guess I made a mistake. And my point is, a Bernoulli DE is just like a linear DE. It's just that I've got an extra factor of y to the end over here. If you could express your DE in this form, I would subclassify it as a Bernoulli DE. And if you do, the substitution we're going to commit to is allowing you to be q, excuse me, I misspoke, to be equal to y to the 1 minus n power.
Prove it.
Yeah, it just sounds so nasty the way I say it, doesn't it? I don't even look at it this way. Because it feels like I'm memorizing anything. I'd rather show you how easy this DE is. So example, number 3. What if I have y prime minus 1 over x times y being equal to negative 5 halves x squared y cubed? Just to make life easy, can I just suppose y is possible? So everybody, clearly this is a Bernoulli dE because it fits that form over there. It fits that form because if I use my clumsy hands to hide this one factor on the right-hand side, that's a power factor for y. That's first order linear. That screams out at me that I'm going to apply this new technique, making that substitution, but I don't look at the substitution that way. I do this. I'm so lazy, I force the right-hand side to be a function solely in terms of x alone. I can easily accomplish that by dividing both sides by y cubed, and I think I'm left with this. So yes or no, do you guys agree? Nobody wants to say anything. You know, that's true, but bottom line is, I at least got rid of all the y's on the right-hand side. Can you guys appreciate how if I allow u to be simply the factor involving y in the second term, it's like I'm trying to force it to be first order linear. But if I allow u to be equal to y to the negative 2 power, notice how its derivative, neglecting a numerical coefficient, is necessarily sitting there in the first term. Because if I treat both y and u as functions in x, and differentiate both sides here with respect to x, I think I see that du dx is nothing more than negative 2y to the negative 3 dy dx. And again, neglecting a numerical coefficient, that's exactly what I have in the first term. And it beautifully, beautifully with the substitution, transforms this dE into one that's first order linear. I think I now have, actually what do I have? Is it a negative 1/2 du dx? Minus 1 over x u, being equal to negative 5 halves x squared. I'll wait for you guys. So you ready for me to generate the integrating factor, since clearly this is a first order linear dE?
No,
Yeah, I'm not either.
you've still got that coefficient.
I still got the negative 1/2 in the way, so I really can't list an integrating factor yet, but in multiplying both sides by negative 2, du dx plus 2 over x times u is indeed equal to a positive 5x squared. I'm so sorry, is that my phone?
That's here. Over there.
It's right there.
I just need to see if this kid's. Nope. So we can say goodbye. And you guys, piece of cake. I take my integrating factor. In terms of x, is going to be, I have no idea, is that an x squared?
Du dy.
That being the case, multiplying both sides by the integrating factor, I think the left-hand side ends up being the derivative with respect to x of the product of my dependent variable, that's u in this case, and my integrating factor. But of course, as I said, I'm multiplying both sides by the integrating factor, so that give me a 5x to the 4th. And I'll undo the differentiation process. I will isolate u. And I'll back substitute, give u its old name back. So that in the end, I clearly see that y squared is equal to my x squared over my x to the 5th plus c. Here too, guys, if you don't mind, I'll just list my solution implicitly. I just don't want to see this sentence. You guys still a piece of cake? I'm hoping. All right. Good, put me to sleep.
Sorry.
It's on. No, no apologize.
Just
Oh.
got back yesterday, so.
I understand. You guys, I want a yes or no answer. Does this appear to be Bernoulli? Just glancing at it, not writing anything down, do you think it appears to be Bernoulli?
Yes.
Yes.
Yeah, I think it does. I mean, if I take the 2/3 root step to the other side of the equal sign, that really would be a q of x times y to the negative 1/2 power. So I would treat it as Bernoulli.
Is Bernoulli a mathematician?
I can look
Is it
up.
this?
Yeah, but I don't remember his first name. It was a pretty common name.
He's got it.
It's like Frederick or something like that.
He's looking it
Also
up.
a physicist. Was he also a physicist? I think I'm not hearing that.
If he was, I'm not aware of that. I only know him historically as a mathematician.
Was it a principal?
What's that?
It's the guy that came up with L'Hopital's rule, that L'Hopital ended up getting credit for. Right?
Yeah, you know, that's happened
Daniel
more than once.
Bernoulli.
Oh, Daniel Bernoulli. Yes, yes, it is Daniel. I remember. You and I, at the end of the semester, or as we get close, we're going to solve DEs with a whole new technique. It's called applying a Laplace transformer. It's a really wonderful mathematical hammer. You and I are going to ding on differential equations and transform it beautifully into just an algebra math D question. It's a wonderful technique. But Heaviside was an engineer, and what happened historically speaking, I just made up a new name, Heaviside, sorry. Laplace was a mathematician, and he developed these Laplace transforms to further his studies in what we call potential theory. And he did not use these Laplace transforms to solve differential equations. But you guys, you understand by now in your mathematical career that historically speaking, mathematicians are typically very snobbish and elites. And one day an engineer at a university discovered that he can apply these Laplace transforms to differential equations, solve them. And so he started using Laplace transforms to solve DEs, and the mathematicians got a hold of this. They were extremely upset. They said, "You can't do that. You didn't prove it works." The mathematicians proved it works, and now we solve DEs with Laplace transforms. But it was Heaviside as an engineer who discovered that. Yeah. That's happened more than once. Yes?
Why did you start using it if you didn't prove it first?
He's an engineer. He doesn't care. It's the mathematicians who are so nutty about wanting to prove everything.
Yeah, you got.
For 3 cases, that was
And since that's the smallest prime number, it was sufficient.
Way you can think about it is mathematician always works it through. Engineer makes a machine to work it for him.
Very good. I agree with that.
Yeah, that's what my dad says. He's a civil engineer, and he forgot how to do all this math just because he has a computer program that does it all for him.
And so he says mathematicians are now useless.
Well, he doesn't remember calculus, which is weird because he's an engineer. But yeah, he says he just has a computer program. And that's how he designs a road. He just types a couple things into a computer program. It just does it for him.
In so many instances in engineering outside the academic arena, a lot of engineers, they typically will do one thing over and over. And yeah, even have software to actually do it for them. And so I hear it all the time from engineers, I don't remember calculus. Or they have children they can't help with their homework because they don't remember calculus. Because they don't
Yeah.
use it, depending what you're really doing with your engineering. So you guys, let's come in. Linear right.
Yep. We need to know math.
Yes? So here, you guys, I think my u sub is going to be y equals 1 to y to the 1 minus m power, which in this case is going to be y to the 3/2 power. I just never remember that garbage. I completely ignore what I wrote over there in parentheses, because if I just simply force this right-hand side to have only a function in x, by getting rid of the y to the negative 1/2, it just screams out at me what the substitution should be to force this DE to be first-order linear. So let's multiply both sides by y to the 1/2. I think I get this. And I will commit to that use of allowing u to be equal to y to the 3/2. Of course, that means u prime is equal to 3/2 y to the 1/2 times y prime, which again, maybe neglecting a numerical coefficient. I have sitting over there in the very first term. That's why the substitution works so well.
So in a test situation, are you going to tell us which one of these to work or use, or
Absolutely
just?
not.
Oh, okay.
You'll be the one making that decision. And committing to my use of everybody. Does that give me is that a 2/3 u prime? Is that a plus root x? U being equal to 2/3 root x? Well, I guess I was right. It yet again transforms dE, this Bernoulli dE, into one that's merely first order linear, with an integrating factor, which is nothing more than, actually, I have no idea. Is that an e to the 2/3? X to the 3/2? You guys make me feel so alone sometimes. I heard one yes. 2 yeses. Okay, we're up to 3. If there's 3 yeses, then let's keep running with this. Sorry. Multiplying both sides by that beast again. Oh shoot, everybody! I just made a mistake.
Yeah, that's not right.
I'm not trying to trick you. I really did make a mistake. Where is it?
Well, when you integrated, you got the 2/3 as the coefficient, but should the 2/3 shouldn't be the coefficient because you have
Well, I was
multiplied
integrating
by 3 over
x
2.
to 1/2.
Or yeah. it's
F to exponent by when you get 3/2. Divide by the new exponent.
So then you'd have 2/3 over 3/2.
Well, no, I'm just saying if I were to integrate x to the 1/2,
Yeah.
don't I up my exponent by 1? Divide by the new exponent.
Oh, yeah. I'm looking at the wrong side of the equation.
So I didn't make any mistakes here, but I did make mistakes by even trying to list my integrating factor because I blew it. I should have cleared my coefficient up front.
Okay.
I need to first multiply both sides by 3/2. So that my integrating factor with respect to x is, oh come on, jeepers. Too pretty.
Yeah, I got it.
And multiplying both sides by the integrating factor, I think forces me to have the left-hand side to be expressed as a derivative with respect to x. Jeepers, I say this too much. Product of the dependent variable with the integrating factor being equal to what I get on the other side. Undoing the differentiation process. Yes, sir.
I didn't get the
Side.
integrating factor part, wouldn't it be e to that?
You guys, should I just stop? I'm just such a mess today. I made another mistake without meaning to make it. I mean, this really is a mistake. What am I missing here? Yeah, it's got to be e to that power. I completely missed it. I think I did it right the last time, but I'm going too fast. All right, so I blew it. I guess that means in multiplying both sides by the integrating factor, the left-hand side becomes such. The right-hand side is such. And undoing the differentiation process, I guess that leaves me with this. And now in actually anti-differentiating what you see in the integrand's position on the right-hand side of that equal sign, I end up getting, oh gosh, I'm too tired to do this in my head.
Is there a reason why that's still a U
Why, what's still a U?
up there? That's that side of it. Because it, in the integral, you changed it back to square root of x.
But I think the only place I see the U showing up is over here.
Oh, right. Then I lost.
And on the right-hand side, is it 2/3?
Is there any reason why you have it written x root x and not x to the 3/2?
I thought it looked nicer.
Okay.
You might disagree. And I think in the end, it just simply tells me use equal to 2/3 plus c times e to the negative x squared x. Or shall I say with one more back substitution, I don't remember, y to the 3/2? I like that. I hope you like it. You know, I take that back. Maybe I don't like it. I think with my notation, I'm not being very consistent, aren't I? I should probably just use fractional exponents or radicals, one or the other, not both. Maybe that's more appropriate. Wow, you guys, this is just a piece of cake. Do you want to see another one or not?